Welcome to the San Jose Astronomical Association Imaging SIG meeting for May 2021. I'm Glenn Newell. I'm sitting in for Bruce, who is traveling. So I will be hosting tonight and also presenting. I'm going to be speaking about a script for Pixinsight called Autointegrate. And then I'll probably have some time to go into a project that I'm working on to hopefully enable San Jose Astronomy Association to start doing star parties again safely without actually sharing eyepieces with people and having people's hands all over the telescopes and whatnot. Which is using electronically assisted astronomy, or is another way of saying, put a camera in place of the eyepiece and do some image live stacking. So I'll be talking about that, and then hopefully it'll be dark enough at that point that Francesco will be joining us. And he will be talking about NINA. It's a data acquisition program. And we touched on that a little bit last time, but he's going to give us a deeper dive into NINA, which is these days, there's a lot of choices in programs you can run. And so NINA is a fairly new one and one that's a little more user-friendly than, say, Sequence Generator Pro, but maybe not as full-featured. But it's getting there. So Francesco will do that, and of course, if we have time in between or after, we can talk about things in general and share some images and stuff if people like. So let's go ahead and get started. I'm going to share my screen. Let's do this guy here. All right, so you can see my slide there. Somebody say yes.
Yep, I can see it.
Okay, great.
And everybody has to unmute first.
Yeah, everybody was muted. Okay. So yeah, as I mentioned, so I'm going to talk about Autointegrate for Pixinsight. This is a script that I recently stumbled across, and I've been using it like mad, and it's really made a big difference in my enjoyment of the hobby and what I can do in Pixinsight in a hurry. So I'm Glenn Newell. I run the hands-on imaging program for SJAA. I'm also on the board of directors, and my email address is there if you want to reach out to me. That's no problem. So we're going to talk about start with some links, and I've already put the links in the chat as to where you can get the script and where you can learn about the script. We'll do a short, like under a minute video, and then we'll talk about where did this script come from, or really how I found out about it and how long has it been around. And then we'll dive into what does it do, and we'll do a couple quick demos, and then we can do some Q&A. On the right-hand side here, one of the things that Autointegrate can do is do a bunch of different color palettes. So here I've shown, I guess, what are there, eight different color palettes for the same data, and then in the center here is what I ended up using, and that's the finished image. So it's just interesting that because it's so quick, you can go through and try all these different color palettes, and it's interesting. Okay, so the home page for the script is here, and we'll jump to that in just a second. And then also, the author seems to be very much tied in with a gentleman that works with or is involved in one of the remote observatory services called SLU. And that's one that may be less known to some of you. They have a little different model of how things go. But anyway, he has also written some books on how to do astrophotography and how to process. And so between the two of them, they've really kind of honed in on a process for both RGB and narrowband processing in Pixinsight. And then the first gentleman here has written this script. So let me jump into that here just to show you. So this is his homepage. And there's a link here to the GitHub where you can get the script. It's a JavaScript. And there's various information on the page here about what it is and how to use it. But we'll dive in deeper. And as I said, there's a couple videos here. I'll be showing one of them in a minute. So I wanted to show you that. And then, and again, these are, you can shoot the QR codes here, or I pasted these links in the chat. The other one here, and I apologize for the 4K monitor. I can make things bigger, I guess.
Hey,
So
Glenn,
this is,
I don't see him in the chat.
okay. Let me get refocused here.
They're in the chat.
Okay.
I see them.
Okay.
I
Problem
see.
is if you joined after it was pasted in the chat, you don't see it. I think you only see what's in the chat when you're in the Zoom.
Good point. All right. Well, if I can figure out how to get to the chat while I'm sharing.
I guess I could copy and paste it again, maybe.
Oh, thanks, Rob. That would be helpful. Yeah. So I was, guess, let's see here. Gonna be a little discombobulated. Okay, so I was saying this gentleman wrote this remote astrophotography handbook, and so he's written a couple books that are available at no cost. They're ebooks, and while it does, at least this one focuses on this particular astro imaging service, there's a lot of good information in there about processing and whatnot. So, and I wanted to show you the site because you know, he really takes you through this script in a lot of details, right? So including giving you some sample data to play with, how to get the script, how to run it, how to install it into the scripts menu in Pixinsight, how to use it. So really kind of just similar to my presentation here, what it does, what the options are, understanding what the options do. So this is a great resource for getting up to speed on this script. So I wanted to provide that. And then let me jump back into the. Okay, so we're gonna do the quick video here, and hopefully the audio comes through okay for you. Or, sorry. Let's try that again. The audio is not really critical, but. All right, let's try buffering. Let's try this again. So basically you put in some subs, click run. You can see some images starting to come up there on the left. And so this is not only doing the, the stacking, but it's also doing some of the, taking you all the way into the nonlinear domain here. So the image that you're going to see here in a minute is almost to the point where you could publish it, right? I mean, this is the point where I would jump off into Photoshop. Is already nonlinear, but it's pretty well digitally developed, and it's in a pretty good shape. So, and you'll see more of that in the demo, but I just wanted to start with that. So I guess this is not so much where did this come from, but how did I hear about it? And I didn't really notice that I had gotten this email back in December. And again, this was from the gentleman that wrote those ebooks. And he mentions that Jarmo, the author, wrote this script at that time, focusing on SLU.com, which doesn't have any narrowband imaging, but now the script has been updated for Telescope Live and iTelescope.net and et cetera for narrowband imaging. I didn't become aware of it until Telescope.live included it in one of their newsletters on March 19th. So I don't know if you were watching my output on AstroBin, you'd notice that suddenly there was a huge increase in publishing things because I was enjoying this script so much. So that's how I found it, and found it in March. So yeah, talking about AstroBin. So this is the top part of my page from AstroBin, and these ones that are circled here are the ones that I have done since I got that script. And then I also went back and revisited some old data, these down here. And then also there's some others that are in the pipeline. So I've really been working this thing and having a lot of fun with it. And also, I'm not super excited about this image. It's, you're not supposed to start with an apology, I guess, in presenting, but this started out as a scratch target, and I was debugging a camera that wasn't working right. And so I hadn't even like framed this, or I wasn't paying attention to the fact that the moon was up or whatever. I was just, trying to fix the camera. And then at a certain point, I decided to just go ahead and collect more data. But because I'm in a white zone here in the East Bay, San Francisco, I need almost 10 hours per filter to get any kind of an image through the noise pollution, or through the light pollution. And so as a result of that, you end up with a lot of sub exposures, and particularly with RGB, because it's sort of, even if I turn the gain way down, it kind of forces you into shorter exposures, and so you end up with a lot of exposure. So in this case, I had almost 11 hours of data, and so it's 399 subs, and that generally, you name your stacking program, and that amount of data can cause some problems, and make you have to break it up into 4 pieces, and then integrate the output of the 4 or something like that. But with this Autointegrate script, I didn't have any problems at all. It just went right through and did it all in Pixinsight without a problem. And I guess you could contrast that too. It's interesting to me that the weighted batch preprocessing script, which is also a JavaScript Pixinsight script, it has a problem with garbage collection memory, and it generally crashes out when you try to use more than maybe, I don't know, 150 subs or something. I guess it depends on your camera size. So this was a stress test for this script, and it came through in flying colors. So unlike the weighted batch preprocessing script, this one is designed to start with calibrated subs because it was really designed to work with these services that provide you with already pre-calibrated files. So yes, these services let you download your own, their calibration files and the data and calibrate it yourself, which you could argue is the right way to go. But again, for speed and convenience, they provide the calibrated versions. So this script starts with that. And it takes you, as I mentioned before, all the way through to a nonlinear state where you could save it as a 16-bit TIFF with no other changes and jump off into Lightroom or Photoshop or whatever you wanted to do your post-processing in, or stay in Pixinsight and finish it. Since I started using it, the UI has changed a little bit, but this is how it's been for the last 16 days anyway. And so there's a lot of options like everything in Pixinsight, but there's a lot of power. But I found that most of the time I just start with everything default. And if you want to use the SHO, the Hubble palette for narrowband, that's the default there. And it just does everything quite nicely. One thing that I really like that is an option is this column correction here, fix column defects. So some of the CCDs on these sites have column defects. An example would be Australia 2 from telescope.live has some big white columns in every sub-exposure. And I personally have struggled with using cosmetic correction in Pixinsight to deal with those types of things and trying to figure out exactly what column they are and putting the number in there and all that. And this just seems to magically do it on its own. So that's really, really great. And we'll get into some of the other options here in the demo.
Hey, Glenn.
Yeah.
On your slide, I didn't notice anything about gradients and stuff. Does it deal with that?
So you have some options here for using automatic background extraction. But generally, I mean, the workflow that I've been using.
Normalization, which I assume to mean
Yeah.
color correction as opposed to gradients, but.
Yeah.
Anyway, you're in a white zone, so you must have
Yeah.
gradients up the wazoo, right? So.
Yeah, well, me personally, I've decided that I like a tool in Photoshop more than some of the ones in Pixinsight for dealing with gradients. It's called Astroflat Pro. And so it's sort of, in the beginning we had Gradient Exterminator, and then this is one that's, I think, better than that. And I find it does a better job for me dealing with gradients than trying to take it out with ABE or something. But I'm certainly not I won't claim to be a Pixinsight expert. So does that help or?
Yeah, thanks.
Okay. So yeah, what happens if you don't have calibrated subs? Well, I've been using the weighted batch pre-processing script to do just the calibration. And I haven't figured out in the latest incarnation of that how you do that, but the older version is still there in the scripts menu in Pixinsight. And there's a checkbox that says, calibrate only or stop after calibration or something to that effect. So I've been using it to do that. And so I do my calibration if I'm, images from home rather than from one of those services. I'll use the weighted batch preprocessing to do all the flats and darks and flat dark stuff. And then I take the output of that and put it in the Autointegrate script. And it seems fairly flexible and intelligent. So you can even take images that you stacked all the way. Maybe you finished the stacking in the weighted batch pre-processing, and then you can just take those master files and dump them in Autointegrate, and it just goes ahead and does the rest of the processing from there. One thing to note is that when in the Windows Explorer, when you go to add data, it comes up with it's looking for FITS files, but you can change it to the star.star and then load in the Pixinsight format files without a problem. I'm sorry, I got to pause for just a second here. Okay, so sorry about that. So here's a list of things that Autointegrate does in Pixinsight for LRGB files. So you can see there's quite a list of things there. And maybe number 12 you were looking for, maybe, or
I don't think so, but
okay.
I mean, I think that's a different, I mean, somebody else can correct me if I'm wrong. But
Okay.
my impression was like dynamic, whatever that's called, and is different than the neutralization, which is sort of something that makes it gray instead of, red.
All right. Okay, so this is where I tell you that, yeah, I'm lazy and I'm using these scripts, but you can get better results by, understanding exactly what each of those processes does and what all the knobs are. And so using them manually in Pixinsight. So of course, there's resources for that. The Pixinsight book, there's lots of online tutorials. And we talked about the gentleman that wrote that book from SLU.com, has detailed processing workflows, and he's updated them to where he starts with the Autointegrate.script and then goes on and uses other things like the easy processing suite and other things in Pixinsight to further process things. So you might want to take a look at that. And you can point your phone at the QR code there to get that link if you want. And then of course, Francesco has presented in the past and will probably again in the future. So past and futures SIG meetings will get you more information on Pixinsight. But for me, as I said, so far it's meant I get a lot more enjoyment out of Pixinsight, and it's really fast. So that's what I like about it. So that, I think, brings us to the demo. So let's go ahead and do some auto integrating. So I'm going to do at least one narrowband and one LRGB here. So I'm going to do NGC 3324. So this is all data from telescope.live. And these are just one-click observations. So basically, for free, you don't have to. I mean, you pay your monthly fee, but I didn't have to go and do an advance request for these and schedule time and all that. So I've got the script installed here under the script menu. So this is the Autointegrate script. And I notice that he presses run first and then adds the files, but that's kind of counterintuitive for me. So I just add them first. So let me navigate here. AstroPix services, Telescope Live, one click. And we said NGC 3324, I believe. Yep. So these are the pre-calibrated lights that came with one or more of those one-click observations here. It looks like maybe two different one-click observations. So we've got 4H alpha, etc. here. So let me just go ahead and pop those all in. And you could, certainly you could blink these first and see if there's any you want to throw out or that there's any column defects or anything. But this I've already know this data is pretty clean. So just go ahead and start. You can hear the jet engine of my computer starting up in the corner there.
You figured out that which file is which filter, I take it.
Yeah, and there's a, some if there's a problem with that, there's some naming conventions that you can do to force it to. Oh, and you saw a big block of red text go by there. There's an error that is in one of the Pixinsight processes that doesn't actually affect anything, but it's you'll see that every time. So now it's underneath the window here. It's already starting to populate some images on the screen. And one of the interesting things about this is that you can do a certain amount of reprocessing without having to start over again. So it seems to keep track of what's where, and this extra processing section down here in the lower right, once it's finished, you can add these options in and then continue on. So we'll do that here in a second. So this is going to be the SHO palette, right? So there's going to be a lot of green for the hydrogen. So if we want to change it to a blue gold color palette here, we can click off a couple options here and just go ahead and say auto continue. And I'm not sure why it has to ask for this, but it does. I think this is just where it's putting the log file. And okay, so it's done. And, we have to, it's kind of a weird thing in Pixinsight where you have to exit the script before you can manipulate any of the windows. But, there's the completed image. And we can just save it as a TIFF and jump right into Photoshop, right? So you just have to jump through all these directories every time. Oops, that's not the right place. Now I've forgotten what the 3324, not 6324. So there's our 16-bit TIFF, and then if we were going to jump into Photoshop, There's our 16-bit TIFF. And, you know, one of the things I like to tell people about Photoshop is you set it up to have TIFF files brought in through Camera Raw, and then you get all your Lightroom type controls over here. And it doesn't always help, but 9 times out of 10, you know, hitting auto and then maybe adjusting the black point will just kind of polish off your digital development there. So that's a great start for a finished image right there. And then I won't bother cropping this or doing much with it here, but just to finish my thought with Hai on the Pro Digital Software AstroFlat Pro is what I'm using to kind of clean things up, and usually just the default settings. And then probably tweak the black point one more time, although that's pretty good right there. So, okay, so that was the narrow band. Any questions on that before I do the LRGB? Okay.
Sorry, I had a question. You had
Yeah.
shown that grid of all the different mappings. Is that something that this tool just generates for you, or did you have to go through and select all the combinations and run it over and over again?
Yeah, I ran it over and over again.
Okay, bummer.
Yeah.
That seemed like it could be useful
But
to just generate all those.
I did share that with the author and Jarmo, and he thought that was interesting and said he should do something with that. So I don't know if that's coming or if he just meant he was going to go off and look at the different colors. I noticed since then he's removed one of the options. You know, there was a Hubble palette natural, which I was actually using. It seems like it's not there anymore, but he's reworked this part of the UI. So there's natural HOO, but not natural Hubble palette anymore. But and one of the things that I kept telling him, you know, that hey, there's no HSO, and he said, well, didn't you know you can just type in these boxes, right? So I had no idea that you could do that, right? Because I just figured, oh, it's a drop down and you have to pick from what's there, but you can put whatever you know, formulas you want in here to do whatever custom stuff you want. And I've done you know, some of the HOO, and I've done some of these Macs where I've had both RGB and narrowband data, and so for any given pixel, pick the max of, right? So you kind of get RGB stars and narrowband data behind it for the nebula. So that's kind of cool. And then I haven't quite
You're
figured
saying-
this.
I'm just saying, so what you're saying is you can write a script for the script?
Well, I think that's kind of
Okay,
well,
I'm joking.
yeah. I guess you could, but that's sort of where I think Rob was going. But for the color palette, you can put pixel math type expressions in here, and it'll just process with those. So, all right. So, in order to, I have to close all these files in order to start with fresh here. So let me do that. Don't need to save any of this. Okay, and then we'll do a quick LRGB. So we're going to do Centaurus A. So we've got luminance, red, green, and blue here. Already calibrated. So we'll do the same thing, just take whatever defaults. And this is a gaming machine that you're hearing over there in the corner. It's a 16 core. So it's pretty fast, but I'm just, speaking comparatively to weighted batch preprocessing or other stacking tools, it seems to be pretty fast.
One
Go
thing
ahead.
is, I think this tool needs a better name, because I've seen it hanging around out there, and I thought
Yeah.
Autointegrate, like I don't need that, like
Yeah.
integration, and I never bothered to look at it, and it's like this is on par with like easy whatever, right? It's like a
Right.
meta easy something, and
Yeah.
from a marketing perspective, I think they need a better name, because I just skipped right over it.
Yeah, and I was about to say that I found it interesting that, the author doesn't even own a telescope. He just uses these services and wrote this for himself.
Mhm.
So I think that, publishing it was an afterthought, but thank God he did.
That's
He
great.
did.
Yeah.
Okay, and for some of the options on this one, you guys can teach me a little bit here. So in the extra processing for both RGB and LRGB and narrowband, this section here can be applied. And oftentimes, and I know from hearing Adam Block and others talk about how they judge at least LRGB photos, that I always have too much contrast and my background is too black, but I generally prefer to add contrast and a darker background. But and I'm sorry, the tooltips jump up there, but
Well, are you doing your images for Adam or are you doing it for yourself?
well, yeah, and that's why I haven't totally, but if you want to win contests on Telescope Live, I guess you got to please them. But anyway, so we can throw the kitchen sink at here, and I'm just sort of assuming that these things are going to give me more detail in finer areas and stuff, but maybe it's appropriate, maybe it's not for this image. But
Clearly, though, you could take whatever it finishes with and then run those processes
right,
on top of it.
yeah, and so you can kind of see through the console here. The original is called Auto LRGB, and then what you do afterwards is called Extra, Auto LRGB _ extra. And I'm just gonna probably putting the data in the wrong place, but okay, so here's two different images that you could, take from there. So, and again, if this data was also clean, and I guess we could do one if we want to with the column correction in it, but it just does a really good job of removing those column defects. Okay. Let's see what else I had here. Go back to the PowerPoint. Yeah, so any more questions on that?
Hey, Glenn, this is Gary. I'm wondering
Yeah.
if this would make a good sort of stair step to learning Pixinsight. I mean, instead of just diving right in and learning Pixinsight from scratch, if this might be a good stepping stone to be able to use Pixinsight on the way to learning the full tool.
Yeah, I would say that's the case, although, you know, a lot of the learning curve, you know, I put Pixinsight off for a long time because it just felt so alien, you know, the different user interface. It's got its own paradigm for, you know, how you close and open windows and how you do processes and stuff. It's just different from any other piece of software, right? So it has a huge steep learning curve. And so, yeah, anything that could help people be more comfortable and more familiar. So this would certainly, I think, get you, you know, like you feeling you're getting your money's worth out in a hurry. And then I guess working through the options in the program would teach you about, you know, some of the individual processes in Pixinsight, but it's not going to help you learn, you know, the user interface and some of those other things that I found difficult. But you know, there's lots of Pixinsight resources out there where one could learn that. But yeah, I think this is a great tool for getting a lot done in a hurry in Pixinsight.
Yeah, thanks, Glenn. Yeah, the Pixinsight demos I've seen, the user interface just seems really, it's very different. Let's put it that way. And I can see what you mean about, because I found it also kind of intimidating. I mean, maybe it's genius and maybe it's you know, I don't know. I'm trying to keep an open mind, but the demos I've seen have kind of like left me scratching my head.
Yeah, I won't argue with you on that. But yeah, I don't pretend to use it enough or be an expert enough to really take advantage of some of those other things. I mean, I do drag processes, you know, like if you want to apply the stretch from the screen transfer function to a histogram, right? You got to drag the triangle over there and do that. So I know how to do that, but that's and I think I understand when to do global and when to do the circle and when to do the square, but there's a lot I'm not doing. I'm not doing projects. I'm not doing history. There's a ton of stuff there that I haven't adopted yet, but that's why, you know, there'll be other people here that can present that are experts at that stuff, and so we can all learn and move forward. Okay, any last call for?
Glenn, does it have anything for OSC?
Yeah, I tried to. It's supposed to work with OSC, and I think I did that once, and I tried it last night, and I got an error, and I felt like I had been there before and figured it out, but I didn't want to work through that. I mean, I got an image out of it. It just errored out before it had completed all of the stuff it wanted to do. So maybe it just needs more than the 5 minutes that I gave it last night. So, but yeah, it's supposed to work with one-shot color.
Thank you.
Yep. Not sure about raw files though. But
Oh, no, you said that they need to be calibrated, right?
Yes, that's true. Yeah, good point. Although, you know, it seems like you can just throw anything at it and it'll just take it, right? So it's not going to complain that you haven't calibrated your files. And like I said, I put, you know, stacked images in and uncalibrated, calibrated, whatever, and it'll process them. one way or the other. Okay, we beat that topic to death. All right.
How do we applaud on this? I can't hit the space button and applaud at the same time.
Okay, all right. So thanks for that. You know, SJAA has a YouTube channel. I have a YouTube channel. We have our Imaging SIG program, and of course, all these things are advertised on Meetup. So, gonna jump then to my other topic, and I won't go. This is turning into a huge PowerPoint here with all the documentation for this project I'm working on, so I won't go through the whole thing, but just kind of give you an overview. So let me just talk for a minute here. So yes, people are getting vaccinated, and yes, we may not have to wear masks soon, but people that provide these SJAA star parties, you know, some of them are older, like myself, and might have other exacerbating conditions like diabetes or something, and they are concerned. They're not ready, even though you know, Governor Newsom or whoever, CDC says you can go without a mask. They're not ready to share their eyepiece and telescope hands-on with a long line of public people at a star party yet. And so I was trying to find ways that, and this goes back almost a year now, you know, for SJAA to still provide, you know, star parties and public outreach and whatnot. So we started with, you know, virtual star parties, and they called it the armchair star parties, right? And so we had a lot of work with the planetarium showing things, and then imagers doing live stacking, you know, via Zoom or YouTube or whatever we used. And so now I'm wanting to do something similar, but a little bit more in person. So you go out under the dark sky, but you don't put your eye on somebody's telescope, and you don't touch their telescope, but you bring your smart device with you, and you can view what they're looking at through the telescope on your smart device. So that's the idea. And so that's a project that's being worked on, and there's going to be a acid test or dry run, or however you want to call it, coming up on June 5th. It's not for the public, but some of us are going to gather at RCDO and see if we can make this project work, and get a lot of feedback from what's easy, what's not easy, and fine tune it before we go and buy all the gear and whatnot. So and there's sort of two phases to this. If you've seen me post on the Google group, for my program, I want to be able to show everything on my screen. I want to stream my screen, right, so that people can see Sequence Generator Pro or K-stars or whatever, and see all the manipulation that we go through while we're imaging. And so I'm going to use some of the same infrastructure for that, but different software, so that each of us that would come to an imaging workshop that wanted to share their screen could do so via, you know, a Wi-Fi network, and people could then see it on their smartphones without, you know, breathing over your shoulder, looking at your laptop screen. So there's that, and then there's what I'm calling SJAA EAA, which is really for the star parties, for the visual observers that are used to using eyepieces. So that's what this is about here. So I'm only going to go through the executive overview part of this presentation, and it's to just describe, my thought process and what how this is going to work. So basically, it's instead of eyepieces, use the public smart devices that they have with them. And the point is to make sure that there's no app that they need to load ahead of time. They don't need any internet or cellular access because it's, a lot of our sites, there is none anyway. So no prerequisites, just show up with your device, and then we'll make it easy to join a local Wi-Fi using a QR code, and that's been tested and that works, both Android and iOS. And then as you go to each telescope, there'll be another QR code that you point your phone at, and then you'll get the image that's being live stacked from that telescope. So just as an example, these would be laminated signs, right? So you come into the star party, let's say RCDO, and there's, usually some docents there, and they could assist you in pointing your phone at this thing to get on the Wi-Fi. And then there's two examples here. As you go to each station, each telescope, they'll have a sign that you focus on, and you can see the image, and then I've got the information that's the QR code is telling you is here in text, just in case for some reason you don't know how to do QR code, or you're more comfortable typing it in yourself or whatever. So that's how that's going to work. And then, if people don't have smart devices, the telescope operator or the presenter at each station could certainly have a tablet that's doing the same thing that they could hold up and share and speak to. So the whole idea is that, the social distance is maintained, and actually, an advantage over a traditional star party is that there'd be less queuing up for the eyepiece, and of course, knocking it out of focus and off target and all that stuff. So maybe a little more kid friendly. I don't know. We'll see. So the concept is also to keep it as just as low tech and as simple as possible, because the people that do public outreach at these star parties, they're not imagers, and they're visual observers, and they love visual observing, and so they don't come with a bunch of computers and cameras and whatnot. So try and keep it just as low tech as possible. So we'll have a couple batteries with an inverter running a router that's going to run for 5 hours, which is way more than we need. We'll have at each station, we'll have a Raspberry Pi, and just two cables, right? Just power for the Pi and a cable for the camera. And then ideally, color one-shot camera would just drop in the eyepiece holder. You do a little refocus, and you're on your way. So that's the goal. And so Hi has helped me, tweak some Python. So we've written our own client, and this is not the final version here, but pretty close. So basically, there's just two controls that they have to deal with: exposure time and gain. And then you've got a stretched image to see what you're looking at, and then you've got a histogram to help you with the exposure. So basically, you turn the exposure time all the way down just so to check your focus and get on target, and then set it longer with the histogram for stacking. This should be some kind of a tracking mount, right? Because we are going to, I'm sort of assuming, I guess, that this won't go well with a DOB or something that's not going to track. Although the live stacking is doing a certain amount of star registration and stuff. But if the exposure is long enough such that the image is blurred because you weren't tracking, then that'll be a problem. So I think we can get away with Alt-Az or GEQ mounts, and certainly you don't have to be auto guiding or anything, but this is all TBD. So yeah, I've been playing around with exposures around 40 to 60 seconds, and then stacking them so that you get a better looking result as time goes on. So this is an early experiment. This was a M1 stack, and again, this was from my white zone here in the East Bay. So that was 22 45-second exposures, but RCDO should be much better. And again, the perceived advantage of live stacking over just long exposures is that you get to show the public something really fast within a minute, and but then it just keeps getting better the longer you stay on that target, and the noise goes away and the detail gets better, and it's also a way to show the color. This was a couple nights ago, just before the clouds rolled in, again from my white zone here, but I was pretty happy with this. So this is an actual capture of the iPad screen. This is what the public would see. So there's your M51. And yeah, I guess I've got the iPhone one later, but anyway. So one of the things is I'm not sure exactly the best way to set this up. So the original idea is the visual observer, star party veteran would do it all, right? He or she, they bring their scope, they set it up, they get on target, they put the eyepiece, the camera in for the eyepiece, they run the software and interact with the public. Well, maybe that's doable, maybe it's not. We'll find out. But maybe a better way would be to have them work in pairs, right? So only one person brings a scope and the other person deals with the public, and that frees the first person up to just focus on the technical tasks. And then, kind of a third idea, and of course, this is kind of an over-the-top picture here, but I'm not sure what this DSLR is doing, but another idea is like we did in the virtual star parties, just go ahead and have a full-on imager there with their rig, and so you get higher resolution, better looking results, but you still have the visual observer working with them, working with the public, and telling the imager what targets they want to see and whatnot. So I think we'll play with all of these and see, maybe it's a combination, see what works best. And so some of the things that we'll be testing out is how easy is it for the visual observers to switch to a camera and get back on focus. I can't make these cameras will not be parfocal with eyepieces. They're going to be, in my experience, they're going to need inward focus, inward travel of at least like 15 millimeters and stuff. And if we decide to use focal reduction, then that's even crazier. You probably have to remove a diagonal or something and have the camera closer to the OTA. Then there's different options for how is the operator going to see the software. So, are they going to bring a laptop, or are they going to use VNC in from a smart device, or am I going to provide a touch screen, or what? Sorry, what? So those are some of the things we'll be testing. And then does that need to be mounted somehow on a telescope, or what? And then, yeah, I mentioned, we could also, rather than mess with the visual scopes, we could also have some imaging rigs there as well. Yeah, so this talks about, the prime focus is equivalent, at least I was messing with an 80 millimeter f7.5 visual scope out in the yard here. And that FOV came out to be the same as like a 7 to 8 millimeter eyepiece. And that's a lot of, that's a really small FOV. So that's why I'm wondering about using a focal reducer, but that brings in the whole problem of back focus, and people have to move their diagonal, remove their diagonal and stuff, and that might be just too much to deal with. And then similarly, for if we want to do planetary, sort of the opposite problem, right? You're going to move the focus point way out with a Barlow, and it's even harder to get on the target with an even smaller FOV. And then software-wise, I haven't dealt with the shorter exposures that we would be using for planetary. At that point, we might jump off into something that's already pre-built for planetary. And there is a program, a free program like that in the Astroberry distribution that we're using for the pies already. Then there's the whole idea of, the visual observers usually don't want imagers there because of the bright screens, and they want to be dark adapted and whatnot. So, with people having to look at screens to deliver this, is that going to be a problem or not? And then if we are utilizing imagers, RCDO is usually on the same night as the imaging workshop. So how does that work? And how do imagers, if they're participating in star parties, how do they get to take advantage of darkish open space authority sites and stuff? So that's kind of as far as I was going to go. I'm building these little kits, and they're labeled with the the last octet of the IP address, and got these little keypad goodies to mouse and keypad things that have worked out really well. So I'm just trying to document this for the visual observers, and I'll there's the splash screen for our application there with the SJAA logo. But I'll do some similar documentation for this is the live stacking program. I'll do some similar documentation for getting the screen streaming going for imagers too, in the next week or so. There's the iPhone capture of that same target. So that's as far as I wanted to go with that. So we've got about 10 minutes before we have to switch to Francesco. If anybody wants to share any images or anything. Anybody have anything they want to share? If not, I will pass the ball.
I didn't have any images, but I wanted to mention that a few weeks back, I don't know if anyone else attended this talk, but I think the Halls Valley or Tri-Valley guys hosted a talk about recovery at Lick Observatory.
Mm-hmm.
And it was a kind of a surreal experience because it was like a bizarro world. It was a Zoom full of different people that I had never seen, but
yeah,
it was like one of our meetings. But at any rate, they had shared that they used this stuff called first contact to clean some of the mirrors of the reflecting telescopes up there. And I had no idea about this stuff, and you can just buy it on the web, and you kind of paint your mirror with it, and it's like a polymer that dries onto the mirror, and then you peel it off, and it cleans all the dirt and junk. So if you have like a big reflector, if you're going to clean it like once every 10 years or something, and you don't want to use water or whatever, cotton balls, this stuff looks like an interesting alternative. So
yeah, Bruce has purchased that and used it on a lot of optics, not just mirrors, but filters and stuff too. So
Yeah, so it seems like it would work pretty well, but of course they were very delicate with it, right? Just painting a tiny corner of the mirror and all that stuff because they have some real telescopes there, but it's pretty
yeah,
cool stuff.
I had the impression it was fairly expensive, so I don't know about.
They have some kits for like smallish telescopes and like it's like $200, you know. So I mean, if it's something you're going to do once every 5 or 10 years, it doesn't seem prohibitively expensive.
Yeah, I just had to replace my my shroud on my truss RC because it, you know, the elastic wore out and it was sagging and all this stuff. So the, you know, some of these things that are outside all the time, the telegizmos and you do have to go through and replace them every once in a while. So, yep. Okay, thank you for that. Anybody else? Francesco, is it dark enough for you to? You're muted.
We can certainly try.
Okay. Well,
This light, but
go for it.
However, I wanted to ask you about, given that you were mentioning cleaning and protecting the telescopes, did you have other bad experiences with yellow jackets?
Oh, this year I didn't have the wasps or whatever they were in my telescope, but there was still, I noticed I did go and do some cleaning this year, and I did notice there was still some mud in there. So yeah, I've just been using a lot of deionized water, distilled water, to kind of just knock the grit off. Try not to touch it with anything.
Right.
And I've been known to put some Windex on there. Don't shoot me, but you know, I keep buying these cleaning kits, and then I can't figure out where I put them. You know, there was one that was stored at HP that disappeared, but you know, it's Dr. somebody's kit that you buy from OPT, and it has a 2-part, you know, solution that you spray, and there's the certain paint brushes that have the right fine bristles on the end that are acceptable and stuff and all that. So there are kits with instructions for cleaning telescopes.
I'm still using some 99% IPA.
Yeah.
That I had bought at Fry's in their hobby electronics section, but now that Fry's has shut down, I will know where to go to get it. Yeah,
this stuff from OPT, you can't ship it outside of the United States. Yeah.
Anyway, thank you, Glenn, and hi everybody. So my name is Francesco. People who know me know that I've been a low-tech imager for the last 4 years. And only this year I decided to do a little jump in technology and try automation. And the reason was that I moved to a place with a decent backyard for astronomy, so I can leave my gear up all night without fear. It's secure enough. And so I needed a solution to be able to image all night while sleeping, and not by staying up all night and babysit the telescope. And so I decided to try this new product that I had read about, NINA, which is an acronym for Nighttime Imaging and Astronomy. It's essentially a one-man show. This Stefan Berg is the main developer. There is a community of developers around it, but Stefan still has the lion's share of the work. And he developed it to be as open as possible. It's open source. It doesn't charge a fee to use, which seems to become harder and harder in these days. Everybody moves to a subscription model. It supports quite a bit of hardware, although it's limited to what is supported by ASCOM. because it is a Windows application. It's written in C#, runs on Windows. There's currently both the 32-bit and the 64-bit version, but the 32-bit will be probably dropped soon. I hear lots of complaints about having to maintain the two versions. So anything that has an ASCOM driver for Windows would work. And even things that are not that common, like my own guider, the Lacerta MGen, had some level of support. What really got me interested is that this level of support, although insufficient, could be easily incremented by changing the software because it's open source. So I found the bugs that this implementation still had relatively quickly, corrected them, and started using exactly the hardware I have without having to buy any new hardware to run my imaging sequence unattended and do things like automatic Meridian flip, plate solving, all things that all of you know very well, but that had been out of my purview for the last 4 years, given that I was only using a DSLR and no computer. So let me see if I can share my Windows desktop. Desktop 1. Yes, perfect. Share. So what you're seeing now, I hope, is my Windows desktop.
Yep, we see it.
It's a remote desktop to my mini PC, which is currently velcroed to one of the legs of my tripod. So it controls the telescope via a USB serial converter, control the mount, sorry. It controls the camera, the focuser, and the guider. And it connects to my home Wi-Fi so I can remote log in. And when I run the application, just a second, it's a mini PC, so it is slow. It's not your 16-core, Glenn, absolutely, not even close. This is the splash screen. As you can see, it asked me to choose a profile. This is an interesting feature that it has, the selection of the profile up front. You can have different profiles for different set of hardware components. Ideas what I have here, I have one profile for my 130mm refractor with the 0.79 times focal reducer, one for the 1.0x field flattener, and one for my 65mm quadruplet. So if I choose this and I do local load profile, there's a number of settings like the image scale, the field of view that will be automatically loaded in the application. Now I have to find a way to reduce, yes, this one. Let me expand it. In this case, as you can see, I have a configuration of a number of devices. And then I have a few other options. The user interface is, for me, it was a little bit awkward because as you can see, there's no menu bar. So this is an application that is entirely probably designed to be used on a tablet. So the more than menus and buttons to click, there are big buttons that you just hover and click. So probably good for pointing with your finger on a touch tablet. Let's say that I want to connect my devices. My profile stores all the devices that I'm using. So I just need to click here and it will ask me, do you want to connect all devices? And I say yes. And it starts polling the devices, just found the camera, the telescope is connected, the focuser, the rotator, and the guider. The rotator in this case, it even supports some interesting virtual devices. I don't have a rotator. This is a manual rotator. What it means is that I can use all the features that a real rotator would allow me to, like changing the position angle of my frame. But when the rubber meets the road, it's going to ask me to go out, rotate the camera using the camera angle adjuster, and then it's going to tell me whether I'm close enough and I can specify the tolerance, or I need to do something more. I find it rather useful to avoid essentially forgetting to change into the position angle that I had decided.
Well, it should also tell your, I guess it depends on if you're guiding with a guide scope or off axis, but
Yep.
I like the manual rotator, although I have a rotator, but I like the manual rotator in SGP because it tells, you know, PhD2, so I don't have to recalibrate PhD2
Yep.
after rotating.
So basically, you have a rotator that acts downstream of the OAG or the ONAG in your case.
Down, well, towards on the OTA side, yeah.
Yeah. Okay.
Yeah.
The program also supports classes of devices that I don't personally have. Well, of course, I'm using a DSLR, so I don't have filter wheel, but supporting the filter wheel is no surprise. It supports ASCOM switches, so you can turn on and off things like dew heaters. It supports ASCOM compatible flat panels, like I think they have the Spiker Flat and the Elnitech and the Artisky flat box, and also the Pegasus Flat Master. I don't have any of those, so when I take my flats, I use the manual option that Nina has, in which I go out with my iPad, I put it on the objective lens, and I take the flats. If you have a weather station, or if you subscribe to one of the internet weather service like Weather Underground, you can download the weather data. And as we will see, there are options. You can use, you can build a sequence of operations that takes into account the weather. Like if the wind increases past a certain threshold, close the dome, close the roof. Which brings us to the dome, which of course I don't have, although it would be nice. And it supports various methods. This is really, I've never seen how a dome automation would work. So I'm not able to go any deeper into this. What is also interesting, it supports a safe.
Francesco, you could have a manual dome. It could go tell you to go outside and cover up the telescope.
Probably, although it would defeat the ability to sleep through the imaging sequence. Safety monitors, I think it would be interesting. You can, as I understand, you can have a number of hardware switches that detect potentially unsafe conditions, like position of the mount or the telescope, or I think rain, it's also a possibility, and would be able to trigger the shutting down, parking the telescope and shutting down the imaging operations for the night. So this is probably less useful if you image from the backyard, more useful if you image remotely, not at 20 feet. But apart from the devices, what is the philosophy of Nina? I don't know how much similar or different it is from solutions like SGP. I never used SGP, but the workflow that I personally use is this. I decide that I want to image a certain object, and I go into the framing wizard, and I decide, and I search for that image. Let's say that I want to image M51. I can load imagery for this object. In this case, it's coming down from one of the sources of data that it has, or it can come from a local cache, so that when you are in the field, you don't lose the ability to do framing. What you lose is just the ability to download imagery data that you don't have in the cache yet. But if you do your homework at home and you prepare the cache, you'll be fine. So then you see that you have your image. You can change the position angle if you want. You can recenter it in a different way. You can decide to create a mosaic. Of course, for M51 would be a completely absurd idea. But when you are happy, you can slew the telescope to the object if you want, or slew and center, which means slew and plate solve and correct. Or you can create a sequence of the sequence is the focus of the image acquisition activity in NINA. Every image acquisition run must follow a sequence, and a sequence is, as the name implies, a set of operations that happen one after the other in time, and you can decide what the sequence looks like by using essentially a programming language, completely visual, by dragging and dropping elements in the sequence. So let me show you what I mean. Let's say that I want to create a sequence to image M51. I will start by using what is called a simple sequencer. So I just added it, and Nina takes me to the simple sequencer. This is very, very simple, probably way too simple for what we like to do. But I can say, okay, I want to image one or more targets. You see here in this arrow up here, I could have multiple targets one after the other, but let's say that I want to start only one. I want to start guiding. I want to, of course, slew to the target. I want to center a target, which means place solve it. In this moment, I don't want to be bothered by rotating the target. Then I will want to do autofocus when the sequence starts. I can refocus when the filters change. I don't have a filter wheel, so it doesn't really apply to me. I can refocus after a certain elapsed time, after a certain number of exposure, after a certain temperature change, or when the half flux radius of the sequence of images already taken is at an increasing progression. When it increases more than 5%, 10%, etc., refocus. This moment, I don't want to do any of this, so I want to take care of deciding what to image. I want to image this galaxy by shooting a total of 10 subs for 300 seconds each. These are light frames. I don't have filter. Binning is 1:1 because mine is a DSLR. And I'm gonna dither every second and use a 100 ISO for gain. If I had a cool camera, I could say, okay, cool the camera before starting the sequence, support auto Meridian flip, and also I could say if the mount is parked, I could say unpark it before starting, and conversely park it when the sequence ends. I don't want, and even warm the camera after the sequence ends. I don't want to do any of this right now. So if this is okay, I would just click the play button and the sequence would start. But as you can see, this is very limited. So in NINA 1.11, which is still not even a beta, it's a nightly, it's a series of nightly builds. They added one new type of sequencer, what they call the advanced sequencer. So if I click this button, I will turn this simple sequence into the version of the same represented in this more powerful programming language, visual programming language, that I will be able to fully customize. So this is the same sequence, but represented in this language. It tells me that I have a target with a certain RA and declination, and it will be imaged at a certain rotation. This is the chart of visibility of this object. When the sequence starts, there will be a set of preparation instructions, which could be, okay, you want to switch to a certain filter. I'm going to remove this from the sequence because I don't have filters here. So I just click the trash can button. I want to slew, I want to center, I want to start guiding, and I want to run autofocus as preparation. And then I want to start imaging. Imaging will have one instruction, which is called the smart exposure. That it basically tells Nina, I want you to take 10 subs, 300 seconds each, of type light with a certain binning, gain, filter, and a certain dithering set. And I can add at this point triggers and conditions to this smart exposure instruction. What's the trigger? Trigger is something that a condition that is evaluated at between one exposure and the next, and can determine the execution of certain routines. The typical example is the meridian flip. If you are nearing the meridian, when each image ends, Nina will evaluate how close to the meridian if you are. If you are close enough to be within the parameters that you have set in another screen, then Nina will stop tracking, will wait to clear the meridian with that's also a parameter that you can specify, will flip the mount, will reacquire the target, refocus if you want, and restart guiding and resume the imaging process. Other examples you can see here are all of the possible elements that I can put in the programming actions, if you want, that I can put in the sequence. I want to turn on the deheater before starting, for instance, or I wanted to cool the camera before starting. If you want to do so, all you have to do is to drag and drop the element. Now, in this case, there's a sign that says, well, this camera doesn't have a cooler, so this is not really going to work. But if you had a dedicated digital camera, this would be an operation that would be executed before starting the sequence. Other things that you can do, if you have a dome, you can open the shutter, you can close it at the end. If you have a flat device, you can say, okay, before changing from one filter to the next, I wanted to close the flat panel cover, take a series of flats. And you can do it just by dragging and dropping again. These are the ones with the lightning bolt are triggers. You can say, I wanted to do autofocus after 10 exposures, for instance. Easy, I drop it here and I say, after exposure 10, do the autofocusing. And this is a counter that will keep track of how many images I've taken in my sequence. I can move the focuser by temperature so that to implement an automatic temperature compensation. If you have calibrated your focuser, this makes it very easy to support that. Dither, of course. And these are loop conditions, which are also interesting. Let's say that you want to image an object from the moment it clears your local horizon to astronomical dawn. Very easy. You just needed to say that you want to wait until the object has cleared a certain altitude on the horizon. Oh, sorry, it's not this one. Yeah, it was wait for altitude, sorry. Okay. I wanted to wait until it has cleared 10 degrees. Or this is 10 degrees over the absolute horizon, or even above the local horizon. There's a module that in Nina where you can specify a file that describes the minimum elevation that your horizon allows for a sequence of azimuth values. And then when you want to say, I want to loop until the object, until astronomical dawn, I just drag and drop this, loop until time, until astronomical dawn. Or let's say that I want to do it either until astronomical dawn or until the object sets below 30 degrees on the horizon, whichever happens first. That's fine. I can drop two conditions. And as soon as one of the two is no longer satisfied, the sequence will exit this loop, essentially. Now, let me remove some of the sequences because I would like to start the sequence and show you what it looks like during the execution of a sequence. Are there any questions about the sequence builder? No, okay. Other interesting things, you can have a preset set of targets that you store and you can retrieve very easily. And you can even, if you are satisfied with a certain sequence of operations and you just want to replicate it just by changing the object, you can turn it into a template. And a template will essentially include everything except for the specification of the object, the coordinates of the object. So you can reuse the same sequence like for OSC or for mono imaging with filter wheels. You prepare the sequence that you want, you save it as a template, and you reiterate it, customizing it each time for the object. In the framing tool, there is actually another option that I didn't show you. When I do add a target to a sequence, I have the option of doing a simple sequencer, which is what I did, or I can use one of the predefined templates. Sorry, not predefined, the templates that I defined, like custom imaging or custom imaging with refocusing between targets. Those are all possibilities. All right, so when I run the sequence, the telescope will slew to M51, will center it via plate solving, we'll start the guiding, and we'll run an autofocus routine. Let's do it. Start. Oh, interesting. It's saying that it's waiting until the target has cleared the horizon because I forgot to remove it. My apologies. Remove this element. Okay, now the telescope is slewing to the target, and while it's doing that, I can move to this other panel, which is the main dashboard for the actual execution of a sequence. The telescope has just finished the slewing. Now it's settling. It waits a specified number of seconds. And this is the plate solving screen. Now it's taking a 5-second exposure. Sorry, 3-second exposure. Now it's downloading, converting the raw into essentially an array and debayering it. My computer is very slow, so be patient. And it's going to show here the image. Yeah, there it is. And now it's using STAP to plate solve this image. And the error right now is 6 arc minutes and 51 arc seconds. Given that I had specified that the error must be less than 1 arc minute, it's going to resync, take another picture, and solve again. Let's see if it's doing it right now. It's downloading the new exposure, debayering it. Now it's going to stretch it and display it here. Perfect. Now plate solve. Plate solved with the 14 arc seconds of error, so that's enough. Now it's choosing a guide star. And it's right now it's doing the calibration of the guider. So it moves the mount in declination and in array, and it calculates how many pixels are per each second of correction. It's gonna take a minute. So I apologize. Still measuring declination. Now I don't have the telescope, my telescope with me, so I cannot show you directly what's happening, but this is the equivalent of using PhD2. My guider is essentially is a hardware equivalent of PhD2. So this would be the calibration in PhD. Or what is it, guiding assistant, they call it. Now it's switched to measuring the calibration in RA. It's going to take another 30 seconds. And then it's going to start showing the guide graph here. I hope that seeing it tonight is not too bad, so we're going to have a quiet guiding. If something is not to my liking, I can go back to the equipment panel. And in the equipment panel, I actually get to see the UI that my hardware guider shows on the field, just without being on the field. But yeah, guiding has started. You see here, it's converging to a 0 position. And at the same time, the system started autofocusing. This window here is the autofocus window. Now it's acquiring the first sample, which will be then compared to the subsequent HFR values from each of the exposures. And Nina would move the focuser between one and the next until he has enough points that it can fit with a, I think he uses an hyperbole. And at that point, we'll determine the position of best focus. Unfortunately, again, my computer is slow, so it's gonna take a while. So this is the first point. It's about 6.5 pixels in HFR, which means that it's way out of focus. Now it's gonna take a second shot. In about 10 seconds, we should be able to see it. The guider is doing all short of bad things because my mount is shaking. And when the focuser motor does big steps, you can actually see it in the guide graph. I apologize. All right, we have 2 points that you can see. In addition to the actual mean value, there's also an estimation of the uncertainty using error bars, which is nice. You can definitely see how the curve that will Nina will try to fit typically is a good, typically fits well within the error bars.
Is that uncertainty just the square root of the number of photons, or is there more than that?
I think that it measures, I think, 100 stars in the image, and the uncertainty is the standard deviation of the various HFR values measured across the field. You can start seeing that it attempts to fit an hyperbola, sorry, in across all the samples. It will take a few more samples to get there because a typical HFR value for good seeing here is about 3.5 pixels for me. So we still have a way to go. Yeah, we're getting there. It was not too bad. I understand if with a faster computer or probably a faster camera, USB 3 or a camera that doesn't require the bearing, it would be definitely faster. And I am happy when I can autofocus in 2 minutes. So as you can imagine, I tend not to do it very frequently during the night. I tend to use temperature compensation. And so I use, I built over time a calibration function from the temperature to the number of steps that I need to command the focuser to move.
I missed it when you said earlier, what kind of computer are you using?
Oh, and this is a $100 mini PC that I got from Amazon. It's a Celeron I think it's a J3500. I should double check. It's 4 gigabytes of RAM, 64 gigabytes of solid state storage. It's not powerful at all, but it's quite cheap. And it does what it needs. You don't need the performance for this kind of activity. It's not like processing in Pixinsight.
Is it running Windows?
It's running. It comes pre-installed with Windows 10. This Windows that you can see, Windows 10 Pro, which is important because Windows 10 Pro has the remote desktop server, and so you just need to enable it, and then you can run it headless and connect to it from a PC like I'm doing right now, from a smartphone, from a tablet, wherever. You don't need to install a VNC or other external tools. You're using the Microsoft native remote desktop. And the V curve starts to take shape, as you can see. This green dot is the current estimation of the best focus point, which means is the local minimum of the hyperbola that best fits these samples. I think it's going to take another 2 or 3 samples, and then it's going to start imaging. In the meantime, I can, you can see this graph. This is the guide graph. There's automatically Nina calculates and shows you the RA and the declination RMS values across this 200 second. I specified it to be 200 seconds x-axis, but it could be 400, 150, or like customizing the software, you can make it pretty much what you want. Given that this had initially was quite a bit off, and then it was suffering from shakes when the motor was doing big steps, I would probably clear this chart as soon as it's done. And it's done now. Now it has estimated that the best position is 9,578 steps at 13.76 degrees Celsius, which is the current temperature. And now it's ready to image. So I'm going to clear the chart and get ready. In 1 second, waiting for the camera. Yes, and the first exposure has started. Now I can move to this other panel, the image panel, that right now contains, well, it doesn't contain only noise, it contains the last image that was plate solved, which is the last autofocus shot that was done a few seconds ago. In 5 minutes, when this is done, it will be replaced with the image that, that will be downloaded from the camera. The image will also be shown as a thumbnail here in the image history part. Its statistical properties will be shown here. The mean value, the median value, the standard deviation, the mean absolute deviation, the HFR and the number of stars, which are of course important. And you can also have a chart that shows you how things are progressing in the sequence. You can customize the chart to show different variables: the HFR, number of stars, the median value, the mean value, standard deviation, mean absolute deviation, temperature, or the RMS guiding value of each sub. Actually, you can show 2 variables, one on the right side and one on the left side, if you are so inclined. And it's useful because at the end of the night, what I normally do, I start the sequence and then I go to sleep. And in the morning, I connect back to via remote desktop to my mini PC, and I see how things have progressed during the night. For instance, if there was a layer of cloud passing by, I would see the median value suddenly rise, and the RMS value typically go all over the place or go directly berserk. When you are reviewing the image, you can also, of course, zoom in and out. In this moment, there's not much to see, but this is the galaxy, actually. And you can even do a zoom similar to the one that you can do in Pixinsight and move the preview. And you can do other interesting things. You can do the equivalent of the aberration inspector in Pixinsight, in which you're only shown the 4 corners plus the 4 midpoints and the center. Or you can plate solve the current image and see where exactly, what are the exact coordinates that you are imaging. You can toggle crosshairs on and off. For some application, it's probably useful. If you are using a Bahtinov mask to manually focus instead of using an autofocus, there is a built-in Bahtinov analyzer that will try to analyze the X shapes that the mask has drawn around your stars and suggest whether you need to move in or out. But there are also other things that you can do. You can do polar alignment. Now, polar alignment, to be honest, is nowhere near the sophistication of the polar alignment that our friend Hai has built into ECOS. This is basically using a pretty rough plate solving around the declination 0 and the near the horizon, or declination 0 and near meridian, and estimate in this disjoint way first the altitude error, then the azimuth error, and then you iterate across the two. There are better methods, and the one that ECOS has is much better for sure. You can also have take a look at the values that your telescope is reporting via ASCOM. You can see the local sidereal time. You can see that meridian flip, you're going to reach meridian in 1 hour 33 seconds, and at some point meridian flip will happen. Right now I'm tracking with the telescope on the west side of the pier. This is the guide rate in RA, this is the guide rate in declination, and hopefully the right extension and declination don't change, whereas altitude and azimuth are changing because the mount is tracking. I understand that there is a new polar alignment routine coming. I'm not the one who built it, so I don't know any further details, but it will be welcome. All right, we are almost there. In 5 seconds, this exposure will be done. 88, 99, 300. Now the image is being downloaded, converted from Nikon RAW to an array of data. The array is now being debayered. In the meantime, the telescope is dithering. The image is being stretched and shown. And this is the first one of the sequence. Now the thumbnail has been is being shown here, and this is the first data point on the chart that will collect all this information from across the night. I can at this point zoom in and examine the guiding, how it was. Yeah, it's not too bad. If for instance, I'm not satisfied with this image, I can just downvote it with the thumb down, and it will be moved from one folder to, no, sorry, its file name will be changed from the file name that the Nina would normally attribute to bed _ the original file name, so you can easily recognize it. And by the way, speaking of naming, Nina, like SJ Pro, can embed a number of fits header values in your files, can embed the array and declination, can embed the temperature, the HFR, the object name. But for cameras just like mine, the DSLR does not support fits metadata in the raw files. This information can also be embedded in the file name. If I move to the option panel, I can show you here that you can, this is the image file pattern that I'm currently using. I'm using the date and a folder for the date, a folder for the image type, so it will be light, flat, dark, etc. And then the file name will be the name of the target, date and time, the filter, sensor temperature, exposure time, and the frame number in the sequence. But you can, these are all the variables that are at your disposal. You can build the names that you prefer. This is the option file. As you can see, there's a number of options that you can specify how the images are stretched, whether they are stretched after debayering, whether the HFR is calculated after debayering or not, whether the stretch is linked or unlinked. This is just like Pixinsight. You can specify the directories where the templates are to be stored, where the sequence files are to be stored. You can specify, this is for the meridian flip, how many minutes after meridian the flip should occur, or how many minutes before the meridian the the telescope should stop. Maybe because there is an obstruction and it would collide into the obstruction. But the interesting part about Nina is that if this does not fit your needs, this can be easily customized. The code is pretty easy to read. And what I did, for instance, was I built the Smart Meridian Flip plugin. This plugin implements a new trigger item that I can find here. Just like there is Meridian Flip, there is a Smart Meridian Flip. In what ways there is my Meridian Flip Smart? You can feed it with a file that's specified for each of the declination angles between minus 90 and plus 90. What is the minimum, the latest hour angle that the mount can safely track to at that declination, and the minimum hour angle that must elapse before the mount can safely flip to the other side. In this way, you can, if you have an obstruction, but only for certain declination angles, you don't need to waste imaging time when you're shooting at a different declination. Nina will always use the minimum wasted time for the flip. So we'll waste the minimum time between the moment that tracking must stop and the moment flip can happen. And building it was relatively easy. You need to have you need to use Microsoft Visual Studio, which, given that I don't have a Windows machine, I installed Visual Studio on this very same PC. You can see it here, and it runs. It's slow, but it runs. So you can actually develop software and extend the Nina with this development environment. All the software is available. All the source is available. It's on. I think it uses Bitbucket, and it's very actively developed. There's they call them nightly build. Well, there's not really one every night, but at least a couple of times a week there's something new that you want to keep your local copy updated with. We have just finished the second exposure, so there you go. You see that the first one had an HFR of 3.26 pixels. The second one has an HFR of 3.12 pixels, and the chart also reflects that. And let's say that I want to see how the night is progressing. So you can see not only the HFR is going down, but also the median is going down. We started with a median ADU of about 4,500, and now we are already below 4,000. So it's becoming darker. And after a while, you're going to start seeing that maybe not all images are perfect. I don't have a perfect mount by any stretch, and you're going to start rejecting some of them. But it's good that you can easily do it here, and so it saves time in the following morning when you have to process in Pixinsight and do frame selection. You can already start dropping some frames. Are there any questions?
Hi, Francesco, this is Paolo. And I've used Nina in the last 3 weeks. I adopted as my reference software. Of course, the sequence is what is catching me, but also the Sky Atlas that you do not mention is very useful for me because I'm lazy, first. Second, because you can use that as a planning tool.
Yep.
And join it with another nice things of Nina that if you go on the general, you can have the possibility to have the specify a file, a text file that give you azimuth and altitude of your local horizon. Yep. And that local horizon is reported on all the nice chart of elevation that you have for all your target.
Yep.
So when you plan, you can plan not, let's say, ideally, but with your actual local horizon, with all your obstruction that you have in your place, especially if you are in a backyard or something like that, like I am.
I have trees. Yep.
Trees, houses, and this and the other. So that's another very nice feature that I think is worth mentioning.
Yes, thank you for mentioning that. You're right. This is so let me quickly show it. This is the Sky Atlas. You can search for various criteria, type of object, the constellation it sits in, the coordinates of the object, the surface brightness, the size, the magnitude, or the minimum altitude, as you were saying, compared to your local horizon. Let's say that I want to see what's available tonight in Ursa Major. Search. These are all the things that are available, that are visible in Ursa Major tonight. And this is the elevation chart for each of them. And if I'm curious to see, how would M101 look like in my camera? So let's send it to the framing assistant. Now we are in the framing assistant. The image is being downloaded from the FITS Sky survey in this case. I don't have it in cache, strangely. Oh yeah, so this is what it will look like with my camera and my focal length. Oh, that's interesting. And I can continue and doing my framing just like I showed you. But another interesting thing is that NINA can be integrated with the Carte du Ciel planetarium. So let me run a Carte du Ciel. Of course, it's not fast. Okay, let's say that I'm using a Carte du Ciel and I'm curious about the Leo triplet, and I choose M66. If I go back to NINA, I can click this button that says get coordinates from the planetarium software. It uses an API call to Carte du Ciel, takes the information and already understood that I was interested in M66, and now it's downloading the M66 image here. So it's going to take a moment, and it's going to show here. Yep, that's it. But the centering is poor, so I can start by doing things in Carte du Ciel and then refine them here. When I'm happy, I can create another sequence item that I'm going to image. Maybe I can put it after my image of the 10 frames of M51 that I'm doing right now. And NINA would automatically execute that sequence. I'm sure that this is nothing new for people who are accustomed to using SGP or other programs like that, or ECOS. Speaking of SGP, I understand, this is really something that I'm not familiar with, so I'm essentially relaying information that I gleaned from the NINA Discord server. They are implementing an SGP compatible set of APIs that is available here, server enabled here. It's, I understand that other software like the Astrophysics APCC can talk to SG Pro. I don't exactly know what for, but people find it useful. And so NINA is in the process of implementing an SGP compatible API. I don't know if any of you uses it.
Yeah, I think what it's for is kind of your smart Meridian flip, because APCC has all that stuff where you can draw a surface where you say, declinations from here and here, exactly what you just described. And then APCC can pass, what the Meridian flip point should be into SGP. So it's a little bit of a hack, but there may be more to it than that, but that's one way that APCC communicates with SGP.
That sounds certainly useful.
It's pretty useful. Yeah, it took a while to actually get it all working, but it works.
I have to say that actually I'm working with another guy on the Discord server because he would like to. He asked me to enhance my Meridian Flip plugin to actually consume the MLM files that APCC produces, so that even without API integration, we can import in Nina the same abstraction profile that APCC has, because apparently in the astrophysics forum, many people have been complaining about this. And it's for me, it was an interesting little project, because when I discovered that I had this problem, that my mount was limiting, I couldn't track all the way to the meridian for declination between 46 north and 63 north. And if I need to stop at like 30 minutes before the meridian, and I cannot flip it before 35 until after 35 minutes after, I wasted 55 minutes in all declination if I want to be conservative to the utmost. So initially I thought, okay, I can just throw money at the problem and buy a half pier, and it would remove much of the problem, given that it's actually colliding with the tripod legs.
Mm-hmm.
Then the curiosity of understanding how to build a plugin for Nina was stronger, and I enjoyed it more than just buying a piece of cast aluminum.
Yeah, I mean, this is kind of too bad, because for years, Ray, at Astrophysics, or his contract programmer for Astrophysics, has been talking about getting these kind of properties into ASCOM, so that you can, say it's safe, safe to flip from this point and not from that point, etc. And it hasn't gone anywhere. And it's actually something that should be in there. But everybody's moving on, so we're just implementing whatever it takes in the capture programs, I guess, to get there.
Yeah. And it's hard to also, my experience is it's hard to explain what it is for. People who don't have this problem of abstraction don't readily understand what you're talking about.
But
So,
that's surprising, though, because it seems like almost anybody with a tripod, it has a problem like this. So with certain piers, and like you said, they make these piers with like an angle in them, and then you can just go all the way around.
Absolutely.
But those are not, most people don't have that, right? So I feel like most people should have this problem, but you're right, it's hard to,
or maybe they have
across
shorter OTAs than I do. I don't know.
Yeah, that was going to be my comment, was if you've got an SCT or something, then you're probably not going to have this problem. But
You're right.
I mean, I have this problem with my refractor, right, which isn't like one of these massive, it's just the TMB 92, but I don't know, maybe I'm doing it wrong.
No, then I'm doing it wrong too. Yeah, so basically this is it. I just wanted to show you what I was saying. This is the UI that my guider has. This is the equivalent. It's a PhD2 in hardware, essentially. This is how guiding is going. It's going to show you in a moment. Yeah, this is the guide star, and these are the imaging parameters. I'm imaging with an exposure time of 2000 milliseconds, so 2 seconds, with a certain gain. And I have a certain guide tolerance in RA, and a certain one in declination with a certain aggression percentage, a certain mode, which is similar to the backlash correction mode in PhD2, I understand. It's way less sophisticated, again, than the multi-star guider that PhD2 has and HI has implemented for ECOS, but it works. It's giving me 0.41 arc second in declination and 0.37 in array, so I'm not going to complain. If there are no other questions, I will stop my sharing and just show you. Yeah, there are already 4 images collected. You can see here the median is going down, and hopefully the HFR shouldn't change too much along the night. So you should oscillate around the 3.2 pixels. All right. Thank you very much. I hope you find it useful.
Yeah, thank you. That was great. Okay, well, we're a little past time here. Any last minute announcements or anything? I don't think Bruce has anything planned yet for the next month's meeting, but he should be back to take up the reins again. Oh, I know one thing I wanted to say was Telescope Live has just announced planetary images with a couple really nice shots that they dropped in their email of Saturn and Jupiter. So I'm not quite sure how it's going to work yet because they mentioned that somebody was going to be there live to help you along. I don't know how that can be sustained, but that's interesting. So that's going to be available in a week or two, I think. So that'll be interesting to have a meter class telescopes doing planetary. So we'll see what happens. And continue to work on getting. I have permission now from the Open Space Authority to go back to Little Uvis. Would have gone a week ago or 2 weeks back, I forget, New Moon weekend, but the weather didn't cooperate. Looks like I'll be at RCDO next month, but maybe we can sneak in the week before, the week after or something. I have to look at the schedule, but we should be back out there pretty soon now. With some social distancing, but at least we'll get some photons. So, yep, that's all I have. So thanks everybody for joining. I'll get this video edited and put it up on the YouTube, and we'll see you next month. Thanks a lot. Yep.
Thanks a lot.
Yep.
Thank you. Thank you to everybody.
Bye.